What's going on, guys? So today I want to go over compounds. This is in the general chemistry playlist, and understanding compounds is a step closer to being able to understand larger systems within chemistry, and this is sort of the meat of what we're interested in. So like we said, like I said last time, we're interested in what happens to atoms when we add things or subtract things from them. In some cases, we'll be adding entire atoms to other atoms. And sometimes atoms even do that to themselves, and they create interesting structures that are fun for us to study and fun for us to exploit for the humankind, for all of humankind. And so we're just going to go into some basic compounds here, and I want to take a look at some examples. And these are some common examples that you're going to see throughout your entire chemistry career. The first one I have here is NaCl. And as you've noticed, I've been drawing these chemicals out in their full-fledged form so you can really understand how they're connected with one another. And so I have NaCl right here. And NaCl, as if you don't know, is salt. It's common table salt. Okay, now I'm not going to go into the bonds, the types of bonds that are involved here yet. I just kind of want to get your feet wet a little bit, get you to understand exactly what compounds are and what they look like. And then we'll go into the types of bonds later. So here, again, this is NaCl, this is common table salt. This is a sodium attached to a chlorine. Okay. Here we have 5 carbons attached to one another in sort of this chain-like fashion. The prefix for 5, I believe Greek prefix for 5 is penta. And so we call this pentane. This is a standard 5-carbon chain molecule where we have 5 carbons, and attached to these middle carbons are 2 hydrogens, and attached to the end carbons are, I forgot to add another hydrogen in here. There's a hydrogen right there. Attached to the end carbons here are 3 hydrogens. And this has to do with something we'll call the octet rule, which we'll go into a little bit later. Right now, again, I'm just getting your feet wet, just helping you understand what compounds look like. Okay? And so this pentane molecule is the same thing as what I drew here. And you're going to be seeing this a lot too, especially in organic chemistry. Stuff like this where each point on this diagram is a carbon. So here we have 1, 2, 3, 4, 5 points here. These vertices, if you will. Each one represents a carbon. And since hydrogen is so abundant in the natural world, we ignore those completely. So if there's nothing else bonded to any one of these carbons, we assume that the rest is hydrogen. Okay, so attached to this carbon is 3 hydrogens, attached to this carbon is 2 hydrogens, attached to this one is 2, 2, and 3. Okay, so keep in mind again that this is a condensed form of this right here. Okay, and this is pentane. Pentane is something that we use to fuel our cars, for example. This is a good fuel that we use. Here I have something called benzene. Okay. Now here so these 2 diagrams are the same. Okay. And what I have here are double bonds. Okay, and we'll get into double bonds later, the complexities of double bonds and stuff like that. And where I have a double bond, so here's a double bond, where I have a double bond is here's that double bond right here. So instead of 2 electrons being shared, we have 4 electrons being shared between 2 atoms. Okay, and when there's 4 electrons being shared, we could say that's 2 pairs or 4 electrons. Okay, and that's what a double bond is where there's 4 electrons involved in the bond. Okay, here we have 4 electrons involved in the bond, and here we have 4 electrons involved in the bond. Okay, all this artwork is mine, by the way. I'm not taking from any website or anything like that. And then again, we have the vertices here. Vertices are the carbons, so we have 6 carbons in a chain, 6 carbons in a chain, and then we fill in the rest with hydrogen. So we fill in the rest with hydrogen. Okay, and how many hydrogens is the rest? We'll go into that. That has to do with the octet rule. Again, I'm just getting our feet wet with compounds here. Okay, and this is benzene. So I'll write the names of these. So this is pentane, or yeah, pentane. And this here is the same as this, and this is benzene. Okay. Ene implies double bonds. Ane implies just single bonds. This benz is a suffix or a prefix for this structure here, basically. And we can get more complex into compounds. And what we'll run into in biochemistry frequently are amino acids. Amino acids, they're the basic constituents of proteins. Those are compounds. Proteins are compounds themselves. Proteins are just very, very complex. Proteins are on the magnitude of hundreds of thousands of times bigger than compounds, because proteins are strings of amino acids conglomerated together to construct a giant molecule. Okay, so proteins are some of the biggest compounds, if you will, in the known organic world. Okay, other examples that we come across are acids. The vinegar that you eat in your salad, that you have with your salad. An acid is something that has an oxygen in it, and it's attached to a hydrogen as well. Anything that you could possibly think of. Water is another very common one. I'll draw water here, actually. Water is hydrogen, 2 hydrogens. Okay, we have 2 hydrogens. The hydrogens aren't bonded to each other. They're bonded to an oxygen. Okay. And then we have those electrons being shared between the oxygen and the 2 hydrogens, and the oxygen has some lone pairs on them, just like this. Okay, this is water. This is something that you'll come across very frequently as well. So here again I have some examples of compounds. So just to reiterate, this is common table salt. So sodium chloride is what we call it. Sodium chloride. Okay, this is pentane, benzene, and water. Okay, that's a brief on compounds. If you like the way I'm teaching, please visit my website if you're interested in tutoring at tristancarmc.com, and I will see you in the next one. Thanks for watching.